Welcome to episode 233 of Build Your House Yourself University by BYHYU. I'm your host and fellow student, Michelle Nelson, and together we'll learn the basics of home design and construction and demystify the building process so we can make informed decisions and build quality dream homes with or without a general contractor. The cost of lumber has increased more than 300% since April 2020. Lumber sold for $348 per thousand board feet before the pandemic and peaked to a record high of $1,500 per thousand board feet in May 2021. Thankfully, prices have begun to fall in the last few weeks. I checked lumber prices today, and they're around $935 per thousand board feet, which is still considerably higher than prices were when many of us started thinking about building. And lumber prices fell several months ago, then went back up. So we're in unpredictable times. So with that in mind, I thought it would be a good idea to revisit an episode I did on two alternatives to traditional stick-built lumber-framed homes. Those alternatives are Structural Insulated Panels, or SIPs, and Insulated Concrete Forms, or ICFs. Both SIPs and ICFs provide both structural framing and insulation components for the house. According to the National Association of Home Builders, the cost of a standard 2,000 square foot home has increased by $34,000 since April 2020. A similar 2,000 square foot house built with SIPs also increased in price, but by only $8,000, or about 30%, according to the Structural Insulated Panels Association. And what about ICFs? GreenBuilderMedia.com reports that before lumber prices spiked, ICFs added $1 to $4 per square foot compared to stick framing. But now, with ridiculously high lumber prices, ICF homes cost about the same as stick-built homes. Perhaps the reason insulated concrete forms have maintained their prices even better than SIPs is because ICFs are not made with wood components like SIPs are. As you'll hear in the mini lesson, SIPs are made with OSB and insulation. OSB, or oriented strand board, is an engineered wood panel. Like dimensional lumber, OSB's prices have skyrocketed. ICFs, by contrast, do not use a wood component. They're made of concrete and insulation. Now, not only are SIPs and ICF houses competitively priced in the current market, but because they're so energy efficient, they typically require smaller, less expensive HVAC units. This may make the final cost of building with SIPs or ICFs slightly below the cost of building with dimensional lumber. The main warning I have for you for deciding to build a SIPs or an ICF construction house is to beware of higher prices that subcontractors might charge for labor for SIPs or ICFs. And that's only if they're not used often in your area. Trades usually charge more for something that's new and more challenging for them. Threading wires and pipes through SIPs and ICFs isn't difficult, but it's different for many subs. And subs charge more for different. Also, installing windows and attaching cabinets to these lumber alternative homes can be intimidating for subs familiar with only stick framing. So, before making a final decision to use SIPs or ICFs, make sure there are builders and/or tradespeople that won't charge you a premium for your non-traditional choice. Now, take a listen to this replay of the mini lesson on SIPs and ICFs to see if they may make sense for your project. Structural Insulated Panels, or SIPs, are not a new product. They've been around for decades. SIPs are made of a core of foam insulation sandwiched between two pieces of rigid sheathing, most often oriented strand board, or OSB. The panels are air-sealed and provide structurally sound framing and insulation all in one. SIPs are used for walls, roofs, and floors. They can be used in place of or in addition to traditional stick framing. So you may decide to build a traditionally framed wall system, but combine it with a SIPs roof, or vice versa. You could combine a SIPs wall system with a roof made of traditional wood trusses. SIPs are factory made, so they can be assembled on site faster than a home can be traditionally framed and insulated. How much faster? Well, with SIPs, the exterior walls of an average 2,000 square foot house can be assembled in just 2 to 3 days. Fully insulated walls will be in place ready for windows. So while it takes weeks to months for houses to be traditionally framed, it takes only days for SIPs framing. And because SIPs are manufactured in a factory, fewer framing materials are wasted. The R value of the SIPs will vary with the panel thickness and the type of foam used in the core. Polyurethane foam has the highest R value at 6 per inch, but it's also the most expensive choice. SIPs panels typically range from 4 to 12 inches thick. Some SIPs manufacturers say that the cost to build a house with SIPs will be only slightly higher than traditional stick-framed house. Here's why. Number 1, SIPs are pre-insulated, so there's no need to purchase additional insulation. Number 2, you'll save on labor. You could save 20 to 30% on framing labor since SIPs are fabricated in the factory, pre-cut, and ready to assemble when they are delivered to the job site. Number 3, SIPs allow for a tighter, more energy-efficient house, which means that you could get away with purchasing a smaller, less expensive HVAC system. Number 4, you'll have reduced heating and cooling bills over time since the house will be so well insulated and airtight. Number 5, because the house goes up faster, you'll be paying less interest on your construction loan. Number 6, you may qualify for federal and local tax incentives by using SIPs. Non-financial advantages of factory-made SIPs are that they're made to be perfectly straight without sagging or bowing that's sometimes seen with dimensional lumber. So installing windows, doors, and millwork is faster and easier. SIPs are also more resistant to earthquake and storm forces than stick-built homes. Because they're made of sheets of OSB or plywood, SIPs provide a continuous nail bed for attaching exterior siding or interior finishes like drywall and molding. A bonus here is that you'll never have to search for a stud again when you're hanging pictures in your new house. Now, this last one is a big advantage. Most structural insulated panels have a warranty. Ever heard of a warranty on dimensional lumber used for traditional stick framing? I didn't think so. Some disadvantages of structural insulated panels are that many builders and subcontractors are intimidated by SIPs because they're unfamiliar with them. Some subs will even refuse to bid on SIPs homes. Other challenges with SIPs are that special tools and sometimes cranes are needed for framing. SIPs can incur termite and moisture damage, so make sure you select a product treated with boric acid, which resists insects and reduces potential mold growth. Because they're factory made, careful project planning and sufficient lead time is required for manufacturing and shipping the product. Lead times may need to be as long as 8 to 12 weeks. And house plans should be very specific about the placement of electrical wiring and outlets, because SIPs need to be manufactured with electrical chases to accommodate wiring. And some electricians, especially the inexperienced ones, find working with chases difficult. House plans should also detail the exact size and placement of windows and doors so the factory can make the SIPs with accurate cutouts. Last-minute structural changes can be pricey and time-consuming since new panels would usually have to be ordered. And what about pipes? Well, pipes should be installed in the interior wall panels using furring strips. Pop quiz. What are furring strips? We talked about furring in episode 15 called Size Matters, but so does climate. Furring or furring strips are thin strips of wood or metal that are attached to a wall and spaced several inches apart. Furring is used for many reasons, but in the case of SIPs, furring would be attached to the panels to provide extra space for pipes. Take a look at the show notes for a photo of how furring on SIPs can provide space for pipes. Other disadvantages of SIPs are that they can be damaged by moisture. To avoid this problem, water-resistant materials should be placed on SIPs as soon as they are assembled. House wrap should be used to cover the panels. Although SIPs are airtight, the house wrap will provide a drainage plane. In other words, the house wrap provides protection against moisture. Finally, depending on how unfamiliar your region is with SIPs, you may need special engineering and code approvals, and you may have trouble finding subs who are experienced with SIPs. If you decide you want to use structural insulated panels on your new home, do some research. Not all SIPs are manufactured alike. Some have better reviews, better quality foam, and higher R values than others. Now, moving on to Insulated Concrete Forms, ICFs. Like SIPs, Insulated Concrete Forms were developed decades ago. ICFs can be used for walls, floors, and foundations. This system is comprised of concrete sandwiched between two layers of foam. The foam is made into interlocking modules that are stacked together without mortar. The units lock together like Legos, and then they're filled with concrete. This type of construction results in a very strong, quiet, energy-efficient envelope that can handle high winds and storms. ICF homes are said to be 10 times stronger than traditionally stick-framed homes. ICFs come in several variations, including straight blocks and waffle-style blocks. The waffle style requires 10% less concrete than the straight forms. Wikipedia suggests that construction costs will be about 3 to 5% higher with ICFs as compared to a traditionally framed home. But like SIPs, ICFs will allow for savings during and after construction. Savings that come from not having to purchase or install insulation, needing a smaller, less expensive HVAC system, having lower utility bills, qualifying for tax credits, and having lower insurance premiums. The lower insurance is because concrete homes are so strong and they're less susceptible to fire, flood, and storm damage. It's a concrete home, so what about wiring and plumbing? Well, wiring and plumbing aren't a problem. The foam is thick enough that it can be grooved out and the wires and pipes can be inserted, and then spray foam can be used to cover the tracks. A hot knife or an electric saw is commonly used to create the openings in the foam for pipes and wires. And what about window and door openings? Window and door openings are measured and cut out of the foam on the job site. Installers leave openings in the walls for later installation of windows. The openings are lined by window and door frames called bucks, B-U-C-K-S. Bucks are traditionally made of wood, but they can also be made of vinyl, foam, or other materials. The buck is secured in place and concrete is poured around it. The typical R value of an ICF can range from R12 to R26, which is pretty good for walls in moderate or hot climates. It may not be sufficient, though, if you want to build an especially high-efficiency home in a cold climate. If you really want an ICF home and you're building in a cold climate, some designers suggest adding exterior rigid foam insulation to the ICFs. Here's another reason why ICFs might not be the best choice for cold climates. The ICF wall has half its insulation on each side of the concrete core. The concrete acts as a thermal mass, which means it can absorb and store heat. So once the heat gets through one side of the insulation, it hits concrete. Because concrete is a thermal mass, it absorbs and transfers a large amount of heat to the ground. That's great if you live in a hot climate where you want heat to stay out of the house. But it's not so good in a cold climate. One of the main challenges with ICF assembly is blowouts. The term blowout is used to describe the rare situation where the concrete blows out of the form. Blowouts usually occur where a damaged form has been installed, or where exterior bracing is inadequate, or when the concrete is not poured at an appropriate rate. Most blowouts are due to operator error, so hiring a concrete company and ICF installer with lots of experience will decrease your chances of a blowout or any other problem. But if a blowout occurs, don't panic because it can be repaired. Both SIPs and ICF systems are typically used for exterior walls, not interior walls. It's not that those systems can't be used for interior walls, but building exterior and interior walls with SIPs or ICFs would be extremely expensive. Most interior walls in single-family homes don't need the amount of soundproofing or thermal insulation that SIPs or ICFs provide. Most people combine exterior SIPs or ICF systems with interior stick framing. You can add fiberglass or mineral wool insulation to interior walls for extra soundproofing. Finally, if you're like me, you're wondering about the design limitations of using SIPs and ICFs. Although curved walls can be achieved with some brands of SIPs and ICFs, houses with simple straight lines are easier and cheaper to construct. So it might be better to limit curves and unusual angles to interior walls. Well, that's it for our basic mini lesson on structural insulated panels and insulated concrete forms. What I've learned over the past several weeks is that no one type of insulation is best for all situations. Exactly what insulation you choose is not as important as achieving the highest R value that your budget will allow. Remember that insulation is an investment that will start paying you back as soon as you move into your home. I hope you found this show helpful. If you did, you can subscribe to the podcast so new episodes will automatically be downloaded to you. If you're listening in iTunes, there's an icon at the bottom right of the screen that will allow you to subscribe or share the episode. Just tap the 3 small dots at the bottom right of the screen. Before we end today's show, let's see how you do on this week's quiz. Question number 1. This is the name of the channel or tube that's strategically placed in walls that allows cables or wires to run through the walls. A. Chase. B. Base. C. Wire face. Or D. Crawl space. The answer is A. Chase. A chase is like a conduit, but it's bigger, and it's used to route wires and cables through a wall. SIPs use chases for electrical wiring. Question number 2, true or false? The R value of SIPs depends on the thickness of the panel and the type of foam used in the panel core. The answer is true. Different manufacturers will use different types of foam in the core of the structural insulated panel. Polyurethane foam has the highest R value, and SIPs range from 4 to 12 inches thick. Question number 3. Although SIPs and ICFs might be more expensive to build than traditionally framed houses, which of the following are ways that you can recoup the added expense of these systems? A. Having to purchase a smaller, less expensive HVAC system. B. Lower utility bills. C. Lower labor costs. D. Lower insurance premiums. Or E. All of the above. I bet you know this one. The answer is E. All of the above. Because SIPs and ICFs are so energy efficient, you'll require a smaller, less expensive HVAC system, and you'll have lower utility bills. Both SIPs and ICFs are quicker and easier to assemble. It takes days to frame a house with SIPs or ICFs, as compared to weeks or months with stick framing. So framers spend less time on the job site, which means lower labor costs. And because these systems are stronger and more resistant to storm damage than stick-framed homes, insurance premiums are usually lower. Please remember that the purpose of this podcast is simply to educate and inform. It's not a substitute for professional advice. The information that you hear is based only on the opinions, research, and experiences of my guests and myself. That information might be incomplete, and it's subject to change, so it may not apply to your project. In addition, building codes and requirements may vary from region to region, so always consult a professional about specific recommendations for your home. Thank you for listening today. I hope you'll come back next week for another episode of Build Your House Yourself University by BYHYU.